Hi everybody, my name is Chris Razier. I'm the Executive Director of the Discovery Science Place. I am here for your Science on the Spot today, and we're going to talk a little bit about waves. We're going to do that by looking at a couple of different things here at the museum. One of them is inside the cave, which happens to be pretty much my favorite place here in the museum. I love our cave. So let's go inside and let's take a look. Right as you walk into our cave, one of the first things you see is this cool cabinet that has fluorescent minerals inside of it. And these minerals, when a certain light comes on, it's called a black light or a UV light or infrared light, you notice they glow. This calcite sample is glowing especially well. And then some of these other samples are glowing a nice green as well. Even after the light turns off, some of the samples will glow just a little bit. It does automatically, the light comes on automatically and goes through 3 different cycles, but you can also press the buttons after it's gone through its cycle. So if you want to take another look, you see that we have long wave light, white light, and short wave light. The white light is what you would expect to see when you turn on the light at your house. So if we press the middle button, the green button, we just get a standard fluorescent light, or this happens to be an LED light. So you can see what the rocks would look like just under normal lighting. But then, if we choose one of the other options, long wave or short wave, these are UV rays, ultraviolet rays. And our eyes can see some of this light, but there's also some of these light waves that our eyes can't see. But these light waves, even the ones we can't see, they put out energy, and that energizes some of the rock. And when that happens, the atoms of the rock get very excited. And when those atoms then give that energy back off, they do so in the form of light. We call that fluorescence. So we're going to press the long wave light. And over here on this side, hard to see because I've got my light on the phone, but you can see that some of these items are glowing a little bit, especially this rock here. It's got a nice yellow glow to it. And then when I turn off the light, you see the difference there. So when I turn on the light, you'll see that yellow glow. And then when I turn off the light, it goes away. So then when I press the shortwave light, that's on this side, I can see how that changes some of these rocks. Again, you can kind of see the greenish, and that great one up at the top that's orange with the green stripe. And again, my light on my phone is kind of making it so you can't see it as well, but when you come to the museum, you can see it very well. And if we look at the top, you kind of see that purple glow. That's the UV light, the ultraviolet light. It doesn't seem to put out a lot of light to our eyes, but it is putting out a lot of energy that our eyes can't see. Very close to our cave is our giant light bright. Most of you guys have probably played with this one before. And if you look at the top here, there's a sign that talks about the visible light spectrum. Light is a form of energy that our eyes can see, but there are lots of other forms of energy that our eyes cannot see. So if we're talking about visible light, the colors that we see, that's going to be in this range right about here. But if you notice, you can go up or down, and the waves get longer and less energetic, all the way to radio waves, which can be very large. Or if you go this way, the waves get shorter in dimension and they get more powerful with more energy, all the way up to X-rays and gamma rays. In the cave, we were looking at this part right here, ultraviolet, which is right above the visible light. So there was some visible light that those bulbs were putting out, but it was about like right here. Some of the energy that was being put out cannot be seen by our eyes. And if you want to remember the different wavelengths of light that our eyes can see, there's a saying that a lot of people use, a lot of science teachers especially. They call it Roy G. Biv. Red, orange, yellow, green, blue, indigo, and violet. Don't have quite all those colors, but I have some of them right here. The Roy G. Biv kind of tells you the order of the light colors as far as the energy level of the waves. So starting with red and then moving to orange, yellow, green, blue, indigo, and violet before you get to the ultraviolet and then on up. The last thing I wanted to show you guys is the mural that is on our annex, because it talks a lot about waves too. First, it's talking about electromagnetic waves. So remember we said the smaller, more high-powered waves like gamma rays and X-rays, that's close to the sun on our mural here. And then as the waves get larger, we go through ultraviolet. Look at that little spot right there that has the Roy G. Biv. That would be visible light, infrared, microwaves. You'll have to excuse Education Director Tim's Jeep there. And then all the way up to radio waves. And notice the waves get larger and larger as you go. These waves, the radio waves, can be very large, larger than the side of a building as far as their length. And they're pretty low energy. The waves on this end are far smaller than what you actually see on our mural, and they're powerful. That's why X-rays can go through skin and show you bones and things of that nature. And then we also have waves of the ocean that are shown here. These waves are not electromagnetic waves. These are physical waves, waves you can actually see. So the waves of an ocean, the waves of a slinky, things like that, that's actually moving material, passing energy through that material. And those are physical waves. So waves are pretty cool. They're a cool part of science. They're how energy is transferred from one place to another. And there's different types of energy. And in the electromagnetic spectrum, most people just think about visible light, but you have everything from X-rays and gamma rays all the way to radio waves that are all part of that spectrum. So I hope you guys have a great day. This is your Science on the Spot. We hope to see you soon.